Alright, we're going to be looking at angles and the unit circle. That's a drawing of what the unit circle would look like. Notice the quadrants, 1, 2, 3, and 4. We've discussed those in the past. Also notice that it's called a unit circle because the radius is considered one unit. The center of the circle is at 0, 0. And of course the angle measurements around are just for the 0 degrees, 90 degrees, 180, 270, and if we went full circle, we would also be back to the beginning, which would then be 360. That red line indicates the initial side. It always, every angle is started, and one leg of it is always the initial side, which is that X portion of the quadrant. And that would be considered 0 degrees. So I'm putting in the others, and let's see, if I wanted to draw a positive angle of 90 degrees, I would start at the term initial side and go counterclockwise to 90 degrees and draw my arrow indicating that's the angle we're talking about. 130, well, that's 90. I need to go 40 more degrees. Again, the arrow is going counterclockwise. 280. Well, I know I have to go past 270, 10 more degrees, and so that is the indicator for 280 degrees. Again, the terminal side. What about negatives? Well, negative 90 would be going down from the initial side. We're going clockwise now, actually. And again, you can see the arrow pointing, showing that that's the angle we're actually talking about. Negative 120. Again, I have to go 90 degrees plus another 30 degrees, and that's about where I would be. A negative 120 degree angle is in quadrant 3. So all of these angles we're talking about are angles in standard position. So again, the initial side is always 0. That's always going to be considered part of the angle. Sketching the graph, 45 degrees is about halfway between 0 and 90. So that's my estimation for that. The arrow pointing upwards, showing that's the 45 degree angle I'm talking about. So your positive angles are always drawn in a counterclockwise fashion. So sketching angles in standard position. 36 degrees we know has to be in quadrant 1. It's less than 45 degrees. So that's about it. 315. I know I have to go past 270. How far? Did a little math at the bottom. Another 45 degrees, which is about halfway between 270 and 0, or 360. So that's where I stopped, and I put my terminal side right there. Negative 150. Again, I'm going down. I'm going clockwise. I go 90 degrees plus another 60 degrees. And there's the terminal side. So drawing these standard position angles I don't believe is too difficult. So you might want to pause the video right now and try these on your own before you look at my explanation. So 85 degrees is just 5 degrees below the 90. We went in a counterclockwise direction. Negative 320. Well, I've started it there. I've gone 3 quadrants, which is 270 degrees, but I need a little bit more. So 320 minus the 270, I need another 50 degrees, a little bit below halfway. And 180 was pretty simple. You start at 0 and you go half a circle. That's the indicator for 180 degrees. Now we're going to be talking about coterminal angles. So two angles in standard position are coterminal if they have the same terminal side. So here's an example. If that's a 135 degree angle, well then coterminal with that, an angle with the same terminal side, would be like the one in blue. It is going to be a negative because I'm going down from the initial side. And a little math, 360 minus 135 gave me 225, except it's negative 225 because I'm indicating I'm going down clockwise from the initial side. So we could say negative 225 degrees and 135 degrees are coterminal angles. And together they do make 360. So, coterminal angles, let's see, for a 300 degree angle, we have to go about 30 degrees past 270. That's a picture of that. So what angle could be considered coterminal? Well, I put it there in purple, violet. If we're heading downwards from the initial side of 0, how many degrees should that be? Well, it should be negative 60 because full revolution would be 360 degrees. So we could say that 300 and negative 60 degrees are coterminal angles because they share the same terminal side. So let's talk about angles that may be greater than 360. How do we draw them? Well, the first thing I'm going to do is actually take away 360, and that's 45 degrees. So this is how it helps me. I start at the initial side, and I went counterclockwise all the way around, one revolution, and then I had to go 45 degrees further. So now let's talk about which of these angles are coterminal. There were 4 different angles, so let's get started. So that's a picture of a 300 degree angle. Again, it's 30 degrees past 270. Well, right there in blue, how many degrees is that? It's a negative angle. It's going down from the initial side. That would be negative 60. So I don't have to draw a negative 60. I already have it there. I know those are coterminal. They have the same terminal side. So that would be a yes. But what about 60 degrees? Where is that going to be? Well, 60 degree angles in the first quadrant. That's not even close. So I know that's no. Now, negative 420, we have to go around one revolution in a clockwise position, but how much further? Well, if I add 60 degrees to that, I'm at 420 degrees, and you can see where I'm at there. So that's blue little portion of the 420 degree angle. The negative 420 degree angle is negative 60 again. So I drew the arrow to show that actually those are the same. So all 3 of those, 300 degrees, negative 60, negative 420, all share a terminal side. So in fact, they are all coterminal. The only one of those that didn't work was the 60 degree angle. So let's find a measure of an angle between 0 degrees and 360 that's coterminal with each given angle. Alright. So you might want to pause the video and at least just try to draw those angles. Now the first thing I think about is, again, 385 degrees is more than 360. How much more? 25 degrees. So in my little drawing on the bottom, I'm trying to show you that it's more than one revolution around. It's about what it would be. So that portion is 25-degree angles, same exact terminal side. Our direction said between 0 and 360. That meets the criteria, so I would say 25 degrees. Again, for the 575, definitely more than 360. I know I'm going to go around more than once. So I've gone full circle, 360. How much further? Well, I have to go another 215 degrees, actually. So that's another 180. And we need a little bit more than that, and we are at 575 in red. Now the blue angle, or the blue line, is me indicating the 215 degrees. So if I just made a 250 degree angle, I start at the initial side and went 215 degrees, it would end or terminate in the same exact location as 575 degrees. The only difference is 575, I've gone around full circle once. Now here we have a negative angle. I'm just taking away 360 to find out I'm going to need to go around once with 45 more degrees. I go clockwise, full circle, plus another 45 degrees. My terminal side is in the fourth quadrant. Now again, I couldn't use negative 45 because that is not between 0 and 360. So I went and just said, well, if I was at 360 and I took away 45, I would have a 315 degree angle, and that's what's indicated in green. So that would be my choice. It meets the criteria. It is at 0 degrees and 360. It's between them. So negative 356 degrees. I go around, but not quite all the way. It's not a full circle. It's only 4 degrees short of a full circle. So a positive 4 degree angle would end in the same exact location as a negative 356 degree angle. Now, of all of those, I think the trickiest one was negative 405. Because of our directions, we had to have an angle between 0 degrees and 360 degrees. So the key vocabulary for this was standard position. Remember, positive angles, you go in a counterclockwise direction from the initial side. Negative angles, you go in a clockwise position. The initial side is at 0, and the terminal side is wherever your angle falls, the other leg of the angle, and the initial side, of course, was the 0. That initial side is always a part of the angle. Coterminal angles. There were 2 angles with the same side, terminal side. And folks, that is pretty much it. You can go back, rewatch it. I hope that's helped you and that you've learned a little bit about sketching angles in standard position in the unit circle.